Hello there, and welcome to Mysteries Beneath Earth. This is a space where our curiosity can settle in, slowing down to the pace of deep time. We wander together through questions that feel vast, distant, and yet somehow profoundly familiar. Tonight, we are not just looking beneath the soil. We are looking beneath time itself, back to an age so remote that it is not measured in centuries, or even in millennia, but in billions of years. We are traveling to a time before the first fossil, before the first continent, before the first ocean. We are going to the Hadean. The name itself, Hadean, is a clue. It is borrowed from Hades, the underworld of Greek myth. It was named by the geologist Preston Cloud in 1972 because for the longest time, this first eon of Earth's history, an eon stretching from the planet's formation 4.6 billion years ago to the start of the Archean 4.0 billion years ago, was imagined as a literal hellscape, a world of fire, magma, and brimstone, perpetually shrouded in shadow and chaos. When we picture our world, we see a blue marble, a swirl of white clouds over vast, life-giving oceans and green, stable continents. It is a portrait of tranquility, a sanctuary in the void. But this Earth, our Earth, is a recent invention. The planet that was born in the chaos of the early solar system was something else entirely. It was a world perpetually dark, not just because the sun itself was younger and dimmer, but because the sky was choked. It was covered in a thick, oppressive, and toxic fog. This fog was not like the mist that settles in a valley. This was the planet's first atmosphere, an atmosphere born from steam, molten rock, and volcanic fury. It was a sky thick with carbon dioxide, nitrogen, and water vapor, laced with compounds we now consider poisons: carbon monoxide, hydrogen sulfide, methane, and ammonia. It was a sky where free oxygen, the gas that gives us every breath, simply did not exist. To imagine this world is to imagine standing on a surface that is barely solid, under a sky that is a heavy, crushing orange or a dull, brownish red. The air is scalding, the pressure immense, and the silence is broken only by the hiss of magma and the thunder of impacts. This is the Hadean, and for 600 million years, this was the state of our planet. How do we begin to tell the story of a time from which no rocks remain? How do we map a world that erased itself? The Hadean Eon is the ultimate cold case. Its clues are not found in cliffsides or canyons, but are hidden in the mathematics of astrophysics, the chemistry of meteorites, and in microscopic, indestructible time capsules trapped in younger rocks. Tonight, we journey into that fog. We will explore how this toxic, fiery world was forged, how it was shattered and reformed, and how, against all odds, this hellish landscape cooled, condensed, and set the stage for the first oceans, the first continents, and, perhaps, the very first stirrings of life. Our story begins not with Earth, but with a cloud. About 4.6 billion years ago, in a quiet spiral arm of the Milky Way, a vast, cold cloud of interstellar gas and dust collapsed. Perhaps it was nudged by the shockwave of a nearby supernova, a dying star seeding the cloud with the heavy elements: iron, gold, silicon, carbon, that would one day make up our world. As this cloud, the solar nebula, collapsed under its own gravity, it began to spin. And as it spun, it flattened into a vast, rotating disk, a protoplanetary disk, spanning billions of kilometers at the center. The pressure and temperature grew so immense that hydrogen atoms fused, and our sun ignited, casting its first, faint light on the chaotic swirl of material around it. This surrounding disk was not smooth. It was a cosmic debris field, filled with particles of ice, rock, and metal. And in this disk, the process of creation began. gravity, the gentle but relentless architect, started pulling these particles together. Tiny grains of dust stuck to each other. Clumps grew into pebbles. Pebbles collided to form boulders. This process, called accretion, is a runaway effect. The bigger an object gets, the more gravity it has, and the more material it pulls in. Boulders grew into planetesimals, small, rocky bodies hundreds of kilometers across. These planetesimals were the building blocks of planets. The early solar system was a violent place, a cosmic construction site with no safety protocols. Millions of these planetesimals wheeled through the darkness, their orbits intersecting, leading to catastrophic collisions. This wasn't a gentle merging. It was a brutal assembly. For millions of years, these planetesimals collided, shattered, and reformed, gradually clearing their orbital paths in the inner, warmer part of the solar system. Where we are, the lighter ices were boiled away, leaving behind the denser, rocky materials. Four terrestrial planets began to take shape: Mercury, Venus, Mars, and our own, the Proto-Earth. This Proto-Earth was a different beast. As it grew, every collision added more mass, but it also added energy. The kinetic energy of an impact, the sheer force of a mountain-sized object striking at thousands of kilometers per hour, is converted into heat. This wasn't just surface heat. It was enough to melt rock at the same time. Another engine was turning on deep within the planet. The gas and dust that formed our world included radioactive isotopes, unstable elements like aluminum-26, potassium-40, and uranium-238. These elements decay over time, a process that releases a steady, powerful heat from the inside out. Trapped beneath a growing mantle of rock, this internal radioactive heat, combined with the relentless energy from impacts, meant that the Proto-Earth was not a solid, rocky world. It was a molten sphere, a glowing, red-hot ball of liquid rock, thousands of degrees Celsius, shrouded in a thin, vaporized rock atmosphere. This is the state our planet was in when it faced the single most important cataclysm of its entire history. A cataclysm that would define its future, give it a companion in the sky, and set the very tilt of its axis. The Hadean had truly begun, not with a gentle dawn, but with an impact that defies imagination. The world was about to be broken and remade under a sky of its own vaporized remains. Let's settle back into that primordial scene. The young sun is lit, but it is faint, casting a pale glow across a solar system that is still a chaotic mess of debris. The solar wind, a stream of particles from the new star, has blasted the remaining gas out of the inner solar system, leaving behind the rocky skeletons of worlds in progress. Among them is a growing sphere of molten rock, the Proto-Earth, sweeping up the last of the planetesimals in its path. This process of accretion, of gathering the world, is fundamental to understanding the Hadean. It is not a gentle layering like a pearl. It is a violent, chaotic bombardment. Imagine the Earth today being struck by an object the size of Texas. The devastation would be absolute. In the late Hadean, such an impact might have happened every few thousand years. And in the very early Hadean, they were happening constantly. This era of formation was defined by energy. The sheer kinetic force of these collisions was staggering. Each impact was an explosion on a planetary scale, the energy from which didn't just carve a crater. It sent shockwaves through the entire planet, melting the crust and vaporizing rock into the sky. This is the first source of the Hadean's heat, the heat of assembly. But the second source, as we mentioned, was internal. The radioactive elements seeded into the planet's material at its birth were now deep inside, trapped and decaying. This radioactive decay acted like a planetary furnace, a slow-burning nuclear engine. This internal heat is not a relic of the past. It is the same heat that, for 0.6 billion years later, still drives our plate tectonics and fuels the volcanoes that vent our planet's interior. In the Hadean, this engine was running far, far hotter. Short-lived isotopes like aluminum-26 were decaying rapidly, releasing immense amounts of energy. So, we have a world being heated from the outside by a rain of asteroids and heated from the inside by its own radioactive core. The result was inevitable. The Earth was molten. This was not a planet with a few volcanoes. This was a planet that was a volcano. It was a global magma ocean, a roiling, turbulent sea of liquid rock, silicate minerals, and dissolved metals, thousands of kilometers deep. The surface temperature would have been well over 2,000 degrees Celsius, glowing a dull, menacing red. And what of the sky? This magma ocean would have had an atmosphere, but it would be utterly alien. It would be a silicate atmosphere. The heat was so intense that the rock itself was boiling, vaporizing into the sky, forming a thick, hazy fog of vaporized sodium, silicon, and iron. This was the first toxic fog, a sky made of rock vapor. As this vapor rose, it would cool slightly, condensing into droplets of liquid rock, and then rain back down onto the magma ocean. A rain of lava, falling from a sky of stone. This phase, this global magma ocean, may have lasted for millions of years. It was during this incandescent, fluid state that the entire structure of our planet was decided. This was the moment of the Great Sorting, an event known as the Iron Catastrophe. Imagine a mixture of oil, water, and sand. If you let it sit, it will separate by density. The sand sinks, the water settles in the middle, and the oil floats to the top. Now, imagine this on a planetary scale, but with molten iron and molten rock. In the homogeneous liquid ball of the proto-Earth, there were dense elements, primarily iron and nickel. There were also lighter elements, the silicates, which are the building blocks of rock. In the molten chaos, the iron was not stable. It was heavier than everything around it, and so it began to sink. This was not a gentle settling. This was a cataclysm. Droplets and streams of molten iron, denser than the surrounding liquid rock, began to fall toward the center of the planet. This mass migration of metal, pulled by gravity, released even more energy. As the iron fell, it displaced the lighter rock, and the friction of this movement generated immense heat, perhaps raising the planet's internal temperature by another 1,000 degrees. This iron catastrophe was a runaway process. As the iron gathered at the center, its gravity pulled in more iron, faster and faster. In a span of perhaps only a few million years, the vast majority of Earth's iron and nickel sank through the magma ocean and pooled at the planet's center, forming the metallic core. This single event is responsible for the world we know. The formation of the core did two things. First, it left behind the lighter, silicate-rich material to form the mantle and, eventually, the crust. It separated the planet into its distinct layers: the dense metallic core, the vast rocky mantle, and the thin skin of the crust. Second, that core of liquid iron is what gives us our magnetic field. The motion of that swirling, conducting liquid metal, churning 4.5 billion years later, generates the magnetosphere, the invisible shield that protects our planet from the solar wind and cosmic rays. Without the Iron Catastrophe, this shield would not exist, and any atmosphere or ocean Earth developed would have been blasted away into space. Just as it was on Mars. So our planet is now structured. It has a core, a mantle, and it is still a roiling magma ocean. It is still being bombarded, but it is alone. It is orbiting the Sun as a single molten world. And then the greatest impact of all occurred. The solar system was still clearing out. There wasn't just proto-Earth. There were other protoplanets, other large bodies in unstable orbits. And one of them was on a collision course with us. Scientific models, supported by chemical evidence from moon rocks, point to a giant impact hypothesis. Sometime in the first 100 million years of Earth's life, a rogue protoplanet, an object roughly the size of Mars, struck the Earth. This hypothetical object has been given a name, Theia, after the Greek titan who was the mother of the moon. This was not a head-on collision which would have shattered both bodies. It was a glancing blow. Theia struck the molten Earth at a shallow angle, a cosmic sideswipe at tens of thousands of kilometers per hour. The energy released is beyond comprehension. It was the equivalent of trillions of nuclear bombs. Theia itself was obliterated. A huge portion of the Earth's own mantle was blasted into space, vaporized instantly. The Earth was struck so hard that its spin was dramatically accelerated, and it was knocked onto its axial tilt, the 23.5-degree tilt that gives us our seasons. In the immediate aftermath of the Theia impact, the Earth was hotter than it had ever been. The magma ocean was re-energized, reaching temperatures of perhaps 5,000 degrees Celsius. And it was surrounded, not by an atmosphere, but by a vast, rapidly expanding cloud of vaporized rock. This cloud was the combined remains of Theia's core and mantle, and a huge chunk of Earth's own. This debris did not escape Earth's gravity. Instead, it was captured. It formed a hot, dense, spinning ring of magma and rock vapor around the equator. The Hadean Earth would have briefly resembled Saturn, but with a ring of fire. This ring was not stable. Gravity quickly went to work again. Within this chaotic, orbiting cloud of rubble, particles began to clump. The material was so hot and so dense that this process was incredibly fast. Models suggest that in a span of perhaps 1,000 years, maybe even as little as 100, the debris ring coalesced. It gathered into a single, large, molten sphere. Our moon was born. Let's pause and try to truly visualize the moment of this great collision. The Hadean Earth, a glowing sphere of magma, is moving through the dark, and in the distance, another, smaller world approaches. This is Theia, a planet in its own right, perhaps 10% of Earth's mass, a world of iron and rock that had formed in a similar orbit. But the dance of gravity in the young solar system is unstable, and its path has now fatally intersected with our own. Theia strikes the Earth not as a meteor, but as a world. The impact is a glancing blow, and the physics of this moment are what define the Earth-Moon system. As Theia hits, it transfers almost all of its angular momentum to the Earth. The Earth, which may have been spinning slowly, is suddenly jolted, its rotation period accelerated to perhaps as little as 5 hours. A single day on the Hadean Earth might have lasted only 5 hours. The energy of the impact is almost entirely converted to heat. Theia is vaporized. Its iron core, denser than the rock around it, plows deep into the Earth, eventually merging with Earth's own core. This impact is the final, massive delivery of iron to the planet's center, completing the process of differentiation. But the lighter, silicate mantles of both Theia and the Earth are pulverized and superheated. A colossal plume of vaporized rock, thousands of degrees, is ejected into orbit. This is not a solid debris field. It is a cloud of plasma and magma, a gaseous disk of silicate vapor surrounding the Earth. The Earth itself is resurfaced. The impact is so powerful that the magma ocean, which might have been starting to cool, is reformed and perhaps deepened to an even more extreme temperature. The planet is, once again, a liquid star. This event, the giant impact, is the leading and most widely accepted explanation for the moon's existence. It solves several key mysteries at once. It explains why the Earth has such a massive moon compared to its size, larger than any other in the solar system relative to its parent planet. It explains why the Earth spins relatively quickly and why it has a 23.5-degree tilt, which is what gives us our seasons. It also explains the moon's strange chemistry. When the Apollo astronauts brought back hundreds of kilograms of lunar rocks, scientists discovered a puzzle. The moon rocks were chemically very similar to Earth's mantle, particularly in their oxygen isotope ratios, which act like a planetary fingerprint. This suggests a common origin. Yet, the moon rocks were bone-dry, almost completely lacking the volatile elements, like water, sodium, or potassium, that are common on Earth. They were also missing a large iron core relative to their size. The giant impact model explains this perfectly. The impact was so hot that the lighter, volatile elements were boiled away into space. The material that formed the moon came mostly from the rocky mantles of Theia and Earth, not the iron-rich cores. Theia's core merged with Earth's, leaving the lunar-forming debris ring iron poor. It is a beautifully elegant, if terrifyingly violent, solution. In the days and weeks following the impact, the Hadean sky would have been unrecognizable. The Earth was the center of a swirling, glowing disk of vaporized rock. This disk, the synestia as some models call it, would have been blindingly bright, a donut of magma extending for thousands of kilometers. But this fiery ring did not last. Gravity is relentless. Within the ring, particles began to accrete, and the moon formed fast, incredibly fast, not over millions of years, but perhaps in a single century or even a single year. A new, molten sphere of rock coalesced from the debris, a companion born from the trauma. And so we have a new scene. The Hadean Earth is spinning wildly, a global ocean of magma. And in the sky above it, hanging impossibly close, is a new, glowing red moon. Today, the moon is 384,000 kilometers away, but the newborn moon was, by some estimates, as close as 25,000 kilometers. It would have loomed in the sky, appearing 15 times larger than it does to us. It was so close that its gravity was a monstrous force. This is the next phase of the Hadean, the dance of the two molten worlds. The Earth was spinning every 5 hours. The moon was orbiting it perhaps every 20 hours. This gravitational relationship was dynamic and powerful. The moon's gravity pulled on the Earth, and the Earth's gravity pulled on the moon. This pull had two profound effects. First, it acted as a brake. The moon's gravity, pulling on the rapidly spinning Earth, slowed its rotation. And in exchange, the Earth's gravity, pulling on the close-orbiting moon, pushed it further away. This tidal acceleration is still happening today. The Earth's day is slowly getting longer, and the moon is drifting away from us at a rate of about 3.8 centimeters per year. In the Hadean, this process was happening at a ferocious rate. The day was lengthening from 5 hours to 10 to 15, and the moon was being flung outwards into a more distant, stable orbit. Second, the moon exerted massive tidal forces. Today, the moon's gravity pulls on our oceans, creating the tides. But in the Hadean, there were no oceans. Not of water, anyway. The moon was pulling on the magma ocean. Imagine tides not of water, but of molten rock. The moon's close proximity would have raised colossal bulges in the magma ocean. Waves of liquid stone, perhaps kilometers high, sweeping across the planet. This constant churning and flexing of the planet's surface would have generated even more heat through friction, keeping the Earth molten for even longer. This gravitational dance was the stabilizing force our planet desperately needed. Over millions of years, the Moon's pull helped to stabilize the Earth's wobble, locking its axial tilt into the gentle 23.5-degree angle we have today. Without the Moon, Earth's tilt might vary wildly, like Mars, leading to catastrophic shifts in climate that would make it impossible for complex life to evolve. The Moon, born of violence, became our planet's anchor. While this dance was happening, the Earth was finally, slowly, beginning to cool. The solar system was clearing of debris. The largest impacts became less frequent. The planet, no longer being stirred by giant tides of magma, could begin to radiate its immense heat into space. The silicate atmosphere, the fog of vaporized rock, cooled and condensed, raining down onto the surface. The magma ocean began to chill from the top down, and a new, solid surface began to form. A thin, black skin of basaltic rock, the planet's first crust, started to congeal on the surface of the molten sea. This crust was not the stable ground we know. It was a fragile skin, constantly breaking apart, foundering, and sinking back into the mantle below, only to be replaced by new black rock. It was like the skin that forms on cooling pudding, a delicate layer over a still liquid interior. And as this crust formed, it trapped the gases that were bubbling up from the planet's interior. The magma ocean was outgassing, releasing the volatile elements that had been dissolved within it. This was the birth of the second Hadean atmosphere. This is the atmosphere that gives us the true toxic fog. As the planet cooled, the volatiles were released. Immense, planet-spanning volcanoes and fissures in the new crust began to vent staggering quantities of gases. This was not an atmosphere of vaporized rock anymore. This was an atmosphere of chemicals. Water vapor, H2O, carbon dioxide, CO2, nitrogen, N2, methane, CH4, ammonia, NH3, hydrogen sulfide, H2S, sulfur dioxide, SO2, and carbon monoxide, CO. This chemical-rich, dense, and utterly toxic fog is what would shroud the Earth for the next hundreds of millions of years. It had almost no free oxygen. It was an atmosphere for a world of chemistry, not biology. And it was this fog, this toxic blanket, that would, in a strange paradox, become the very thing that saved the planet from freezing. Let us stay with that image for a moment. A molten Earth, spinning in 5 hours, and a colossal, glowing red moon hanging in the sky, 15 times larger than the one we know. This is the new reality of the Hadean, a reality forged in the debris of the giant impact. The Synestia, that ring of vaporized rock, has coalesced, and our companion has been born. This moon was not the pale, dead, cratered world we see today. Too was a magma ocean. It was born so hot and so fast that it was entirely molten. It glowed in the Hadean sky, a secondary source of light, a dull red lantern in the perpetual smog, and its influence was profound. We spoke of the tides, but it's worth digging deeper into that visual. The gravitational pull of this new, close moon on the Earth's own magma ocean was a force of constant, violent change. It would have created a tidal bulge of molten rock, a permanent wave kilometers high, that the Earth's rapid rotation tried to drag ahead of the moon. This gravitational friction was a break, a massive one that the Earth's rapid 5-hour day began to lengthen. And as a consequence of the conservation of angular momentum, the moon was pushed away. This tidal recession was, in its first few million years, incredibly fast. The moon was flung outwards, its orbit widening, its gravitational grip lessening with every passing year. We are seeing the very end of this process today, with the moon drifting away at the gentle pace of a few centimeters a year. In the Hadean, it was a dynamic, rapid separation, the Earth and Moon separating like partners at the end of a violent dance. The Moon's most important gift, however, was stability. A planet's axial tilt, its obliquity, is not naturally stable. Without a large moon, Earth would be like a spinning top wobbling without rhythm. Its axis would tilt wildly over millions of years, sometimes pointing straight at the sun, sometimes completely away from it. This would create catastrophic climate instability. One pole might face the sun for decades, baking it, while the other froze. Then it would flip. The moon's gravity acts as a gyroscopic stabilizer. It holds the Earth at its 23.5-degree tilt, ensuring that our seasons are predictable and mild. This stability is a non-negotiable requirement for complex, long-lived life. The Theia impact, in its violence, gave Earth the anchor it needed to one day become a garden. While this celestial dance was playing out, the Earth itself was transforming. The age of the global magma ocean was ending. The planet was now cooling. The initial searing heat of the giant impact was radiating away into the blackness of space. The magma ocean, no longer being violently churned by impacts or extreme tides, began to cool from the top. A skin began to form. We can imagine this as being similar to the crust that forms on basaltic lava flows in Hawaii today, but on a global scale. A thin, black, fragile crust of rock, floating on a sea of magma. This was the planet's first solid ground. This primordial crust was not stable. It was a chill crust, and it was constantly under assault. Below it, the magma ocean was convecting, with hot plumes of liquid rock rising and cooler rock sinking. This motion would have constantly cracked the thin crust, pulling it apart, causing it to founder and sink back into the mantle, only to be replaced by new black rock. Furthermore, the solar system was still a dangerous place. While the giant impacts were over, a steady rain of smaller, though still enormous, asteroids and comets continued to pummel the planet. Any section of this new crust that survived for a few thousand years was likely to be shattered by an impact, its fragments sinking back into the magma. This was a world of black, glassy rock, riddled with fissures, glowing red from the heat below, and pockmarked with fresh craters. And from every crack, every fissure, every impact site, the planet was breathing. This is the process of outgassing. The magma ocean and the mantle beneath it was saturated with dissolved gases, the volatile compounds that had been part of the original solar nebula. Water, H2O, carbon dioxide, CO2, nitrogen, N2, methane, CH4, ammonia, NH3, sulfur dioxide, SO2, hydrogen sulfide, H2S, and hydrogen, H2. As the pressure dropped at the surface and the rock began to crystallize, these gases were released, bubbling up from the interior. This was the true birth of Earth's enduring atmosphere. The silicate vapor atmosphere was gone, condensed back into rock. This new atmosphere was a chemical one dot, and this is the toxic fog of our journey. Let's paint a picture of it. It was, first and foremost, dense. The amount of carbon dioxide being released was staggering, perhaps creating an atmosphere with a surface pressure 10, 50, or even 100 times what it is today. Breathing this air would be impossible, not just for lack of oxygen, but because it would crush our lungs. It was hot. The surface was still radiating immense heat, and this dense blanket of greenhouse gases trapped that heat. The ground temperature was hundreds of degrees Celsius. And it was toxic. It was a chemical soup. The air was thick with sulfur compounds, the hydrogen sulfide giving it the smell of rotten eggs, the sulfur dioxide the acrid smell of a struck match. It was rich in methane and ammonia, and crucially, it was anoxic. There was no free oxygen, O2. Oxygen is a highly reactive gas, and in the Hadean, any oxygen that appeared was immediately bound to other elements, like iron, forming rust, or hydrogen, forming water. The sky under this fog would have been a strange and oppressive sight. The dense CO2 and sulfur aerosols would have scattered light in a way that made the sky appear a dull, hazy, brownish orange. The sun, already 30% dimmer than it is today, would have been a faint, blurry disk. And this atmosphere was absolutely full of water. The most abundant gas released by this outgassing was H2O in the form of steam. The planet was so hot that all of its water was in the air. The Earth was a planetary-scale pressure cooker, a scalding steam world, a dense chemical fog under which a fragile black crust was trying and failing to fully separate a roiling magma ocean from a sky full of steam. This is the world that existed for tens of millions of years. A dark, hot, pressurized chemical reactor. But this state could not last. The planet continued to radiate its heat. The interior was cooling, and eventually the surface temperature, even with the thick greenhouse blanket, began to drop. It was approaching a critical threshold, a tipping point that would change the face of the planet forever. It was approaching the condensation point of water. This phase change would unleash the greatest storm the planet has ever known. A storm that would last for millennia. A storm that would take the planet from a steam world to a water world. The Hadean fog was about to collapse, and in its place, the first ocean would be born. The great deluge was coming. Let's pull back from the sky and return to the ground, or rather, the lack of it. The Hadean Earth, in its first tens of millions of years, was dominated by the magma ocean. This concept is so alien that it is worth our time to sit with it, to truly try and comprehend what it means for a planet to be liquid. This was not a surface layer of lava. This was an ocean of molten silicate rock, estimated to be at least 1,000 kilometers deep. It may have been global, or it may have been a patchwork of magma seas, punctuated by temporary, foundering crusts. The temperatures at the surface would have been around 2,000 degrees Celsius, and at its base, where it met the forming core, perhaps twice that. It was a turbulent ocean. Just as our water oceans have currents, the magma ocean was in constant, violent motion. It was convecting. Hotter, less dense magma from the deep interior would rise in massive plumes, spreading across the surface, releasing heat, and then cooling, becoming denser and sinking again. This motion was fast, perhaps meters per second, creating a roiling, churning surface that glowed like a furnace. This is the environment in which the Earth's very structure was forged. We spoke of the Iron Catastrophe, the great migration of iron and nickel to the center. This was the Hadean's defining act of creation. It's important to understand that this was not just a sorting of materials. It was a profound chemical and thermal event. As the iron sank, it didn't just fall. It interacted with the silicate magma it was falling through. This process chemically stripped the mantle of certain elements that, like iron, the siderophile elements, pulling them down into the core. This includes not just iron and nickel, but also the vast majority of Earth's precious metals: gold, platinum, and palladium. The gold in our wedding rings, the platinum in our catalytic converters, is only here because a tiny fraction of this material was delivered after the core had formed in a late veneer of asteroids, saving it from being locked away 3,000 kilometers beneath our feet. The formation of the core also released a staggering amount of gravitational potential energy, converting it to heat. This heat of differentiation was a one-time event that supercharged the magma ocean, making it even hotter and ensuring the planet would remain molten for millions of years. So, the Iron Catastrophe gives us our core, and by extension, our magnetic field. This invisible shield, the magnetosphere, would become critical as soon as the atmosphere began to form. The young sun, though dimmer, was tempestuous. It blasted out a solar wind of charged particles far more intense than today's. Without a magnetic field, this wind would have scoured the planet's atmosphere, stripping it away layer by layer. Mars, a smaller world that cooled faster, its core solidifying, lost its magnetic field. As a result, its atmosphere was thinned to almost nothing, its water lost to space. The Hadean Iron Catastrophe, a process of unimaginable violence, is the reason our planet is not a dead, red desert. It is the reason we have an atmosphere and oceans to talk about at all. As the magma ocean churned, it also set the chemical signature of the mantle. The mantle, that vast layer of solid but plastic rock beneath the crust, is the engine of our planet. Its slow, convective roll, like a pot of thick soup on a low simmer, is what drives plate tectonics. The chemical composition of that mantle was set in the Hadean as the magma ocean cooled and crystallized. The first crystals to form in this cooling magma would have been heavy, iron, and magnesium-rich minerals like olivine. These crystals, denser than the liquid magma, would have snowed downwards, accumulating at the base of the mantle, forming a new layer. The remaining liquid magma, now depleted in iron and magnesium, became richer in lighter elements like silicon, aluminum, and potassium. This process, fractional crystallization, is key. It meant that the material that would eventually rise to the surface to form the crust was a different composition from the bulk of the mantle. It was a lighter, more buoyant rock. This is the seed of the continents. The Hadean magma ocean wasn't just a fiery sea. It was a planetary-scale refinery, separating the heavy, core-forming metals, the dense, mantle-forming minerals, and the light, crust-forming minerals. This entire hellish roiling system was, in essence, the planet's childhood. It was the messy, chaotic, energetic phase of formation that every terrestrial planet must go through. And our planet, being the largest of the inner rocky worlds, had the most heat, the most energy, and the most dramatic childhood of all. But nothing, not even a magma ocean, can stay hot forever. The planet was a giant radiator, and the cold vacuum of space was a perfect heat sink. The Hadean Earth was cooling. The surface, exposed to the blackness, was cooling the fastest. This is where the first skin of the planet formed. This primordial crust was likely what we call ultramafic. A rock called komatiite is one of its likely analogs. Komatiites are volcanic rocks that are so rich in magnesium, they only melt at incredibly high temperatures, over 1,600 degrees Celsius. We don't see them erupting today, because the mantle is no longer hot enough. But in the Hadean, this was the first rock to solidify. It would have been a dark, almost black, glassy rock. And it would have been incredibly dense. This density is a crucial point. This first crust was denser than the magma it was floating on. Imagine an ice cube that was denser than water. As soon as it formed, it would sink. This is what happened to Earth's first crust. A black, solid skin would form, only to become unstable, break apart, and founder, sinking back into the magma ocean, its mass consumed and recycled. For millions of years, the surface of the Earth might have been a dark, cracked plain of komatiite, constantly foundering and being replaced. This process, vertical tectonics, is a stark contrast to the horizontal plate tectonics we have today. There was no stable ground, but with every cycle, the magma ocean lost more heat. With every foundering of the crust, the planet was stirred, bringing more hot material to the surface to radiate its energy away. The cooling was accelerating. Eventually, the magma ocean cooled enough that the crust that formed was no longer dense enough to sink. It was becoming more like the basalt that forms our ocean floors today. It was buoyant. It could float. This was the moment a lid could finally form on the planet. A stable, solid, global crust. This crust was the barrier that separated the molten interior from the atmosphere above. And it was this crust that allowed the planet to take its next critical step. Because as this crust solidified, it did two things. It trapped the planet's internal heat beneath it, slowing the cooling of the mantle, and it provided a cold surface above it. This cold surface was now facing a sky still choked with the toxic fog, an atmosphere composed almost entirely of high-pressure steam, carbon dioxide, and nitrogen. The stage was set. The surface was now, for the first time, cooler than the scalding atmosphere above it. The toxic, steamy fog, which had held the planet's entire water budget in gaseous form, was about to meet a cold, black, rocky surface. The greatest rain in history was about to begin. Imagine a world finally at rest from the chaos of its own formation. The giant impact is a fading memory. Its debris now coalesced into a large, close moon. The magma ocean, after millions of years of roiling, has finally chilled enough to form a lid. This is the first true crust of the Hadean Earth. This crust, this first skin, was unlike anything we know today. Our modern world has two types of crust. There is the dense, thin basaltic crust that makes up our ocean floors. And there is the light, thick, granitic crust that makes up our continents. The Hadean crust was neither as we discussed. The first rock to solidify from the magma ocean was likely a dark, heavy, magnesium-rich rock like komatiite. This skin was unstable, constantly sinking. But as the mantle continued to cool and differentiate, the magma that fed the surface became more evolved, more basaltic. This new, global crust was a stagnant lid of black basalt. It was, in effect, a single planet-wide tectonic plate. It was rigid, but it was also thin, and it was still incredibly hot. The heat flow from the mantle below was perhaps 20 times greater than it is today. This immense heat, trapped under the lid, had to escape. It did so through cracks, fissures, and volcanoes. But these were not the cone-shaped volcanoes we picture. This was a heat pipe world. The crust was riddled with locations where heat from the mantle could punch through, creating massive, plume-fed volcanoes. We can see an echo of this today in places like Hawaii or Iceland, but in the Hadean, this process was happening everywhere. The planet was covered in thousands of supervolcanoes that continuously resurfaced the planet, paving over the old crust with new, black lava flows. This first skin was dark, volcanic, and utterly barren. It was a global landscape of black rock, sharp and glassy, broken by fissures glowing red from the magma below, and it was under constant assault from space. This is the era of the Late Heavy Bombardment, or LHB. While the Theia-sized impacts were over, the solar system was not yet clean. Astronomical models, primarily the NICE model, suggest that around 4.1 to 3.8 billion years ago, the giant planets, Jupiter, Saturn, Uranus, and Neptune, shifted in their orbits. This gravitational disruption was a catastrophe for the inner solar system. It sent a shower of debris, asteroids from the asteroid belt and comets from the Kuiper belt hurtling inwards. For a period of 100 to 300 million years, the Hadean Earth and its new moon were subjected to a ferocious final assault. The moon, which has no atmosphere or tectonics to erase its history, still bears the scars of this period. The mare, the dark seas on the moon, are not seas at all. They are enormous impact basins like Mare Imbrium that were carved out by asteroids hundreds of kilometers wide during the LHB. These basins later filled with dark basalt, creating the man in the moon we see today. Now, imagine what this bombardment did to the Earth. Earth, being larger and having more gravity, would have been hit far more often and far harder. These were not dinosaur killer impacts. They were civilization sterilizing impacts. An asteroid 500 kilometers wide would not just create a crater. It would create a shock wave that would circle the planet. It would vaporize the rock it hit, blasting a plume of superheated vapor into the toxic fog. The heat from its reentry would be so intense it would boil the surface of the oceans. A large enough impact could, in fact, vaporize the entire global ocean, turning the planet back into a steam world, a pressure cooker, for thousands of years until it cooled and rained again. A sufficiently large impact could even punch through the thin Hadean crust, exposing the mantle beneath, creating a temporary new magma ocean. This is the environment of the Hadean, a fragile, black skin, constantly being resurfaced by its own volcanoes, and periodically shattered by impacts so large they could boil the sea. This is the hell of the Hadean. And yet, we have evidence that this picture of a hellscape is not the entire story. The most precious, profound, and mysterious clues from this entire eon come not from rocks, because no Hadean rocks have ever been found, but from microscopic survivors. They are called detrital zircons and the Jack Hills of Western Australia. There is a formation of metamorphic rock, a 3.0 billion-year-old metamorphosed sandstone. This sandstone is ancient, but it's not Hadean. But within this sandstone, geologists found tiny, glittering crystals, no larger than a grain of sand. They are crystals of zircon or zirconium silicate. Zircon is a remarkable mineral. It is incredibly durable. It is chemically inert, resistant to weathering, and has an extremely high melting point. When the rock it forms in, like granite, erodes away, the zircon crystals are left behind. They are washed down rivers, deposited in sand, and eventually get incorporated into new sedimentary rocks. They are nature's ultimate time capsules. The true magic of zircons is that they are perfect for dating. When a zircon crystal forms, it incorporates uranium atoms into its crystal lattice, but it strongly rejects lead. Over time, the uranium atoms decay into lead at a fixed, known rate. By measuring the ratio of uranium to lead within a zircon, scientists can determine its age with astonishing precision. When scientists dated the zircons from the Jack Hills, they found many that were 3.5 billion, 3.8 billion, 4.0 billion years old. But a few of them were older, much older. They found crystals that had formed 4.2, 4.3, and even 4.4 billion years ago. This was a profound discovery. A 4.4 billion-year-old zircon is a grain of mineral that formed just 160 million years after the Earth itself. It is a direct, physical relic from the Hadean Eon, a piece of the first skin. These tiny messengers carry more than just their age. By analyzing their chemistry, scientists can read the story of the world they were born in. First, they looked at the oxygen isotopes. The ratio of different types of oxygen in a rock reveals the environment it formed in. The Jack Hills zircons had an oxygen isotope ratio that was heavy. This heavy signature is the hallmark of a rock that formed from magma that had interacted with liquid water. This was revolutionary. A 4.4 billion-year-old crystal was telling us that the Earth had liquid water on its surface, not 4.0 billion years ago, but 4.4 billion years ago. Second, scientists used a geothermometer based on the amount of titanium trapped in the zircon. This analysis suggested the zircon formed at a temperature of around 680 degrees Celsius. This is not the temperature of a magma ocean. This is the temperature of a wet magma, the kind that forms granite, the kind that forms continents in the presence of water. The hellish Hadean model was suddenly in trouble. These tiny, indestructible grains were painting a very different picture. They were telling us that in the Hadean, as early as 4.4 billion years ago, the planet was not just a global magma ocean. It had cooled enough to have a solid crust. It had cooled enough for that toxic, steamy fog to condense. It had cooled enough to have oceans of liquid water. This is the cool early Earth hypothesis. It doesn't erase the volcanoes or the late heavy bombardment, but it suggests that in the between times, in the lulls, the Hadean was not a world of fire, but a world of water. This makes the story of the first skin far more complex. It was a black, basaltic crust, yes, but it was pockmarked by impacts and covered by a global liquid water ocean. And under that ocean, in that crust, the first seeds of continents may have been forming. This water world, shrouded in its toxic fog, was the true cradle of the planet. The magma ocean has cooled, and a thin, black skin of basalt has solidified, forming a global stagnant lid. This lid is hot, but it is solid. Below it, the mantle churns, and through it, volcanoes and fissures vent the planet's interior. This outgassing has filled the sky. The atmosphere is now a dense, heavy blanket, perhaps 100 times the pressure of today's. It is composed almost entirely of the planet's volatile budget. The most abundant of these volatiles is water, H2O, which has been released as steam. The Hadean Earth is a pressure cooker, shrouded in a global, scalding fog of its own steam. This is the atmosphere that holds the toxic fog in its grip. The other components are a chemical brew that would be fatal to us. Carbon dioxide, CO2, is the second most abundant gas, creating a greenhouse effect on a scale we can barely imagine. Nitrogen, N2, a stable, inert gas, is there in large quantities, just as it is today. And then the toxins, methane, CH4, ammonia, NH3, hydrogen sulfide, H2S, sulfur dioxide, SO2, hydrogen, H2, and carbon monoxide, CO. This fog is the Hadean's defining feature. It is the boundary between the planet and space, and it is the key to everything that happens next. First, let's consider the appearance. The sheer density of this atmosphere would make the sky oppressive. The methane, interacting with sunlight, even faint sunlight, would create a complex organic haze. We see this today on Saturn's moon, Titan, which is shrouded in a thick, orange smog of tholins, complex organic molecules created by sunlight acting on methane. The Hadean fog was likely similar. It was not white and fluffy. It was a thick, orange-brown, photochemical smog, blotting out the stars. The faint sun would be a diffuse glow behind this haze. The close, molten moon would be a larger, dull red glow. The world was a place of darkness and shadow, a perpetual toxic twilight. The sulfur compounds, H2S and SO2, would add another layer. These gases, vented from volcanoes, would create sulfuric acid aerosols, a stinging, acrid mist. The smell of this world would be overwhelming. The chemical bite of sulfur and the rotten egg stench of hydrogen sulfide mixed with the sharp scent of ammonia. This fog was also the planet's incubator. It was this thick, heavy blanket that trapped the heat from the Earth's cooling interior, keeping the surface temperature at several hundred degrees Celsius. And it was this blanket that held the planet's entire inventory of water in a gaseous state. But the planet itself was changing. The crust, the first skin, was now in place. It was radiating its heat, but it was also providing a surface, a solid boundary, and the planet continued to cool. The top of the atmosphere, exposed to the cold of space, was radiating heat away. Slowly, painstakingly, over millions of years, the entire system, planet and atmosphere, was losing energy. The temperature of the atmosphere began to drop. It fell from 400 degrees Celsius to 350 to 300. It was approaching the critical point of water. The immense pressures of the Hadean atmosphere. Water doesn't boil at 100 degrees Celsius. It might stay liquid up to 300 degrees or more, but eventually the planet cooled below that threshold. Somewhere on the planet, perhaps at the cooler poles or high in the atmosphere, the first drop of liquid water condensed from the steam. This was the tipping point. The condensation of one droplet released latent heat, which warmed the air around it, but the overall cooling of the planet was relentless. That one drop was followed by another and another. A mist formed, then a cloud, and then the rain began. This was not a storm. This was a deluge on a geological timescale. It was the moment the sky, which held an entire ocean's worth of water, began to fall. That it was a rain of scalding, acidic water. The water was hot, hundreds of degrees. And it was acidic because it had dissolved the CO2 and sulfur compounds from the atmosphere, creating a rain of carbonic and sulfuric acid. This rain fell from the orange-brown fog onto the hot, black, basaltic crust. At first, the ground was so hot that the rain would have sizzled, steamed, and boiled, instantly returning to the atmosphere. A cycle of flash boiling that would have created a chaotic, misty, violent surface, a world trapped between steam and liquid. But the rain was cooling the crust. With every drop that fell and boiled, it took heat from the rock. And the rain was relentless. It did not stop for days or weeks or years. It may have rained for thousands of years, millennia of unbroken, scalding, acidic downpour. Eventually, the crust cooled enough that the water no longer boiled away. It began to pool. It filled the lowest lying areas first. Small puddles became ponds. Ponds became lakes. Lakes became seas. The impact basins from the Late Heavy Bombardment, some of them thousands of kilometers wide and kilometers deep, were the perfect collecting pools. The rain fell, and the great basins began to fill. Over thousands or millions of years, the steamy, toxic fog collapsed. The water transferred from the atmosphere to the surface. The immense atmospheric pressure began to drop. The sky literally thinned out as the water vapor, its main component, was removed. What was left was a thinner atmosphere, still rich in CO2 and nitrogen, still toxic with methane and ammonia, but it was no longer a steam bath. And what was below was a new world. The Earth was no longer a magma world or a steam world. It was a water world, a global, acidic, and hot ocean, covering almost the entire planet, dotted with the volcanic peaks of impact craters. This is the world that the Jack Hill zircons told us about, a world with liquid water 4.4 billion years ago. This great deluge had another profound effect. The scalding, acidic rain was a powerful solvent. As it fell on the first skin of black basalt, it began to weather the rock. It dissolved minerals, pulling elements like sodium, potassium and calcium out of the rock and into the new ocean. This process began to neutralize the ocean, taking it from acidic to something more balanced. The salts and minerals that dissolved in this first ocean are the ancestors of the salt that is in our seas today. The Hadean Earth was now a warm, salty, global ocean under a thick orange, toxic sky. And this new world was facing a deep and baffling problem. It was a paradox that, without the fog, would have ended the story of life before it began. The planet had cooled, the oceans had formed, and now the Earth was in danger of freezing solid. We have arrived at a pivotal scene. The Hadean Earth is no longer a world of fire, but a world of water. The Great Deluge has fallen, a storm of millennia, pulling the planet's water budget from the sky and onto the surface. We are floating on a global, warm, and salty ocean, perhaps kilometers deep. This ocean is dark, its waters rich in dissolved iron, giving it a murky, greenish-brown hue. Above us, the sky is still toxic. The steam is gone, but the atmosphere remains a dense, heavy blanket of carbon dioxide, nitrogen, and a hazy organic smog of methane. The pressure is still immense. The sun is a faint, diffuse glow behind this orange-brown fog, and the large, close moon still dominates the sky, its gravitational pull creating restless tides in this new, global sea. The planet has cooled, and now it faces a profound and existential crisis. A problem so deep it is known in science as the faint young sun paradox. The paradox, first proposed by astronomers Carl Sagan and George Mullen in 1972, is simple. All astrophysical models of stellar evolution tell us that stars, as they age, get hotter. They burn through their hydrogen fuel, their core contracts, and their fusion rate increases, causing them to gradually brighten. Our sun is 4.6 billion years old and in its stable middle age. The sun of the Hadean Eon, 4.4 billion years ago, was a faint young sun. It was, by all calculations, about 30% dimmer than it is today. This is a catastrophic problem. If you were to take our modern Earth with its current atmosphere and place it under a sun 30% dimmer, the effect would be immediate and devastating. The planet's average temperature would plummet to well below freezing, perhaps minus 20 degrees Celsius. The oceans would freeze solid from the poles to the equator. The Earth would become a snowball, a white, icy world reflecting what little sunlight it received, locking it in a permanent deep freeze. Yet, we know this didn't happen. The evidence from those 4.4 billion-year-old Jack Hill zircons is unequivocal. They formed in the presence of liquid water. The Hadean Earth was not a snowball. It was a water world. So how do you have liquid water on a planet that should be frozen? The answer, it turns out, was in the very thing that made the Hadean so alien: its toxic fog. The planet was saved by an extreme greenhouse effect. The paradox is solved not by a hotter sun, but by a thicker blanket. The Hadean atmosphere, born from the outgassing of the magma ocean, was the most powerful greenhouse insulator the planet has ever had. The key ingredient was carbon dioxide, CO2. Today, CO2 is a trace gas, measured in parts per million. In the Hadean, it may have made up 10, 20, or even 50% of the atmosphere. The atmospheric pressure at the surface might have been 10 or 100 times higher than today, and most of that pressure was CO2 and nitrogen. This colossal quantity of CO2, thousands of times our current levels, trapped the faint heat from the young sun. It also trapped the heat still radiating from the Earth's own cooling core. It was a planetary-scale insulation, keeping the surface temperature of the new oceans well above freezing. The Earth was not warm despite the faint sun. It was warm because of its atmosphere, But CO2 may not have been alone. Methane, CH4, is an even more potent greenhouse gas, molecule for molecule. The early atmosphere, rich in hydrogen and carbon monoxide, was a perfect chemical factory for producing methane, both through geological processes, serpentinization, which we'll explore, and through photochemical reactions in the sky. This methane not only added to the greenhouse blanket, it also created the organic haze we spoke of. This is the Titan model. On Saturn's moon Titan, a faint sun and a methane-rich atmosphere create an anti-greenhouse effect, as the haze blocks sunlight. But on the Hadean Earth, the balance was different. The methane haze may have acted as a shield, but not against heat. It shielded the surface from the young sun's ferocious ultraviolet, UV, radiation. Today, we are protected by the ozone layer, O3, but ozone is made from free oxygen, O2, which did not exist in the Hadean. Without an ozone layer, the surface of the planet would have been sterilized by UV rays. The methane smog, the Tholin haze, may have been the planet's first UV shield, a toxic organic sunscreen that allowed the complex chemistry of life to begin in the waters below. So, the toxic fog was the planet's life support system. It was the insulator that kept the water liquid. It was the shield that protected it from UV radiation. The very air that would kill us in an instant was the only reason the planet was habitable at all. This creates a picture of a world in a delicate, alien balance. It is a world of warm, global oceans, covered in a thick, orange-brown smog. The air is dense, unbreathable. The silence is profound, broken only by the hiss of rain, the rumble of volcanoes, and the tidal pull of the moon on the dark water. This balance, however, was about to be shattered. The planet had survived its formation, the giant impact, and the great deluge. It had solved the faint young sun paradox. But the solar system was not finished with it. The gravitational dance of the outer planets, Jupiter and Saturn, was reaching a critical point. Their orbits were shifting, and in doing so, they were about to unleash a final, terrifying storm upon the inner worlds. The lulls in the Hadean were temporary. The era we call the Late Heavy Bombardment was about to begin. The fragile, watery, fog-shrouded cradle was about to be subjected to a sterilization event, a rain of fire that would, paradoxically, provide the final ingredients for life. We have settled into a deceptive quiet. The Hadean Earth is a water world, a global greenish-brown ocean of dissolved iron boils under a dense, orange sky of CO2 and methane. This toxic fog is the planet's thermostat, solving the faint young sun paradox and keeping the world warm. The first fragile crust has formed, and the planet has found a strange alien equilibrium. This entire period, from the formation of the moon around 4.5 billion years ago to this moment, around 4.1 billion years ago, is sometimes called the Long Lull. It was a 400 million year span of relative calm. But this calm was the precursor to a storm, a final cataclysm that would reshape the planet and deliver the building blocks of life. This was the Late Heavy Bombardment, or the LHB. The NICE model, a simulation of the solar system's dynamic evolution, provides the most compelling script for this event. It suggests that the four gas giants, Jupiter, Saturn, Uranus, and Neptune, did not form in their current, stable orbits. They were initially in a much more compact configuration. Over hundreds of millions of years, their gravitational interactions slowly caused their orbits to migrate. Around 4.1 billion years ago, a critical resonance occurred. Jupiter and Saturn, the two titans, crossed a gravitational line, a 2:1 resonance, where for every one orbit Saturn completed, Jupiter completed two. This alignment was a gravitational bomb. It destabilized the entire outer solar system. The orbits of Uranus and Neptune were flung outwards, scattering the vast primordial disk of icy planetesimals that lay beyond them, the Kuiper Belt. At the same time, this gravitational chaos destabilized the asteroid belt between Mars and Jupiter. The inner solar system, which had been relatively quiet, was suddenly flooded with a new, intense storm of debris. For the next 100 to 300 million years, a rain of fire fell upon the inner planets. We see the evidence etched onto the surface of the moon. The moon acts as our witness, a control group. It has no atmosphere, no oceans, no plate tectonics to erase its history. When we look at the moon, we see the scars of the Hadean. The mare, the dark seas that form the man in the moon, are not seas at all. They are colossal impact basins, some over 1,000 kilometers wide, like Imbrium, Serenitatis, and Oriental. When scientists dated the rocks from these basins, brought back by the Apollo missions, they found a stunning coincidence. They all seem to have formed in a narrow window of time, right around 3.9 to 4.0 billion years ago. This suggested a cataclysm, a sudden and violent spike in the impact rate, rather than a slow, steady decline. The Earth, being a much larger target with far stronger gravity, would have been hit exponentially harder. The lunar record implies that during the LHB, Earth would have been struck by over 22,000 impactors large enough to create a crater 20 kilometers wide, the size of a major city. At least 40 impactors large enough to create 1,000-kilometer basins. A handful of super impacts, asteroids or comets over 500 kilometers wide, the size of a small country. This is the rain of fire. We must try to comprehend what this would do to the water world we just described. A small LHB impactor, the size of the one that killed the dinosaurs 66 million years ago, would strike the ocean. The energy would be incomprehensible. It would vaporize a huge column of water, punching a temporary hole in the ocean and the crust, exposing the mantle. The shockwave would create a global tsunami, a wave of water kilometers high, scouring the entire planet. The heat from the re-entering debris would boil the upper layers of the ocean. A large LHB impact, a 1,000-kilometer basin former, would be a global sterilization event. It would strike the planet with such force that its heat would vaporize the entire global ocean. The Hadean Earth would be reset. The water would be blasted back into the sky, reforming the scalding, high-pressure steam atmosphere. The planet would, for a few thousand years, become a steam world all over again. The surface rock would melt. The toxic fog would be temporarily boiled away, replaced by an atmosphere of steam and vaporized rock. Then, as the planet cooled, the Great Deluge would happen again. The sky would fall, the oceans would reform, and the cycle would repeat. This cycle of bombardment, vaporization, and reflooding may have happened several times. The Hadean was not a single, steady state. It was a world of violent oscillations. This seems like the end of any hope for life. How could life begin, let alone survive, in a world where the oceans are periodically boiled? But here is the paradox. This rain of fire, this agent of destruction, was also the agent of creation. These impactors, asteroids, and comets were not just sterile rocks. They were delivery vans. The comets, flung from the outer solar system, were rich in water ice. While most of Earth's water came from its own interior, from outgassing, the comets of the LHB topped off the oceans, delivering a final, crucial percentage. More importantly, these objects, especially the carbon-rich asteroids and comets, were laden with the building blocks of life. They were full of complex organic molecules. Not life itself, but the ingredients. We know this because we find these molecules in meteorites today. The Murchison meteorite, which fell in Australia in 1969, was found to contain over 70 different amino acids, the very building blocks of proteins. It contained sugars, alcohols, and the nucleobases that form RNA and DNA. The LHB was a 200-million-year-long shower of organic chemicals. It was seeding the new, warm Hadean oceans with the exact raw materials needed for life to begin. The comets delivered water and organics. The asteroids delivered more organics, but also metals like iron and nickel, which are crucial catalysts for biological reactions. The impacts themselves, in their violence, created new chemical pathways. The shock wave of an impact can synthesize new organic molecules from simpler atmospheric gases. The Hadean was a planetary-scale chemistry experiment, with the impacts providing the reagents and the energy. This bombardment also had a profound geological effect. It shattered the stagnant lid of the first crust. These colossal impacts punched holes in the crust, creating massive fault lines, ruptures, and melt zones. This may have been the event that unstuck the planet's surface. The LHB, in its violence, may have been the trigger that initiated plate tectonics. By breaking the single stagnant lid into a mosaic of smaller, mobile plates, the bombardment set the stage for the dynamic, recycling planet we know today. The LHB was the Hadean's final act of violence and its ultimate act of creation. It left the planet shattered, but it also delivered the water, the organic chemistry, and the geological dynamism needed for the next and most mysterious chapter. As the bombardment faded around 3.9 billion years ago, the Earth was once again a warm, global ocean. The toxic fog of CO2 and methane was reestablished. But now that ocean was a rich, complex chemical soup. It was a primordial soup. The stage was set. The ingredients were present. The planet was quiet. And in that quiet, in that darkness, something new was about to stir. The great rain of fire has subsided. The late heavy bombardment, after 200 million years of chaos, has tapered off. The final, large impacts have sent their shock waves through the globe, and the oceans have recondensed from steam for the last time. We are now at the very end of the Hadean, perhaps 4.0 billion years ago. The world is finally stable. It is a planet of water, a truly global ocean, perhaps with only a few volcanic islands poking above the surface, temporary scars from the recent bombardment. The water is warm, salty, and acidic, rich with the dissolved minerals from the crust and the newly delivered metals from asteroids. And it is a chemical soup. The toxic fog above, a mix of carbon dioxide, nitrogen, methane, and ammonia, is in constant interaction with this ocean. Lightning from massive, volcanically induced storms flashes through the fog, synthesizing new organic compounds. The young sun's ultraviolet radiation, though shielded by the methane haze, still penetrates, driving chemical reactions. And the ocean itself is now saturated with the organic building blocks delivered by the LHB: amino acids, sugars, and nucleobases. The entire planet is a laboratory, a prebiotic world. The ingredients for life are everywhere. But ingredients are not a recipe. A pile of flour, eggs, and sugar is not a cake. The great mystery, the one that sits at the very heart of the Hadean, is how these simple, dead molecules assembled themselves into the first living, replicating, metabolizing cell. This is the question of abiogenesis, the origin of life from non-life. And the Hadean Ocean offers us the most compelling stage for this event. For a long time, the dominant theory was the primordial soup model, championed by Stanley Miller and Harold Urey in the 1950s. They imagined that life began in a warm little pond, or perhaps in the surface waters of the ocean, where the ingredients, energized by lightning or UV light, linked together to form the first complex chains, like proteins and RNA. The Miller-Urey experiment was iconic. They zapped a flask containing the gases of the toxic fog methane, ammonia, water, and hydrogen with an electric spark. After a week, the water turned a cloudy, reddish-brown. It was full of amino acids. They had, in a flask, demonstrated that the building blocks of life form easily in Hadean-like conditions. But this model has a problem. The ocean is vast. While the ingredients are present, they are dilute. The chance of the right molecules finding each other in the correct order in a global ocean is vanishingly small. Furthermore, water is a problem. The very bonds that hold proteins and RNA together are broken by water, a process called hydrolysis. Life needs water, but the assembly of life's first polymers is difficult in it. This has led to a more recent and incredibly compelling alternative. A model that moves the cradle of life from the sunlit surface to the crushing, absolute darkness of the ocean floor. The Hadean crust, as we know, was thin, hot, and cracked. The new, global ocean of water was now seeping down into those cracks, percolating deep into the crust, toward the heat of the mantle. As this cold seawater moved down, it heated up to hundreds of degrees. It dissolved minerals from the hot rock, becoming a scalding, acidic, metal-rich fluid. This superheated fluid, now buoyant, would then search for an escape route, a fissure, and vent back into the ocean. This is a hydrothermal vent. Today, we see these vents on our ocean floor. They are called black smokers. They are chimneys or spires of mineral deposits, gushing black, superheated water over 350 degrees Celsius that is rich in sulfur and metals. And surrounding these vents, in total darkness, is a thriving, dense ecosystem, not of plants but of bacteria and archaea which feed on the chemicals. They perform chemosynthesis. They eat hydrogen sulfide, the rotten egg gas, instead of sunlight. Now, let's imagine a Hadean hydrothermal vent. It would be different. The ocean water itself was anoxic, no oxygen, and acidic, rich in dissolved CO2 and iron. The vent fluid gushing out would be hot, alkaline, the opposite of acidic, and rich in dissolved hydrogen, H2, methane, CH4, and hydrogen sulfide, H2S. When this hot, alkaline fluid met the cold, acidic ocean water, a remarkable thing would happen. The interface between them is a double gradient. A temperature gradient, hot to cold, and a chemical gradient, alkaline to acidic. This is, in essence, a battery. The minerals precipitating at this boundary would not form a black smoker chimney, but a porous, spongy tower of iron and sulfur minerals. These minerals would create a maze of tiny, microscopic pockets or pores. Each pore, each tiny mineral-walled bubble, becomes a microscopic laboratory. The ocean water flows in from one side, the vent fluid from the other. The mineral walls of the pore, rich in iron and nickel, act as catalysts, the same catalysts life uses today. In this contained, protected space, the chemical ingredients, CO2 and H2 from the vent, are concentrated. The chemical gradient across the pore wall provides a constant, gentle flow of energy, a proton gradient that is exactly the same kind of energy that powers every living cell today. This is the hydrothermal vent hypothesis. Life did not begin in a dilute, sunlit pond. It began in a dark, warm, mineral-rich, microscopic labyrinth on the Hadean seafloor. In these pores, the energy gradient could drive the synthesis of simple molecules into longer chains. The iron-sulfur minerals would catalyze the reactions. The concentrated soup inside the pore would allow these molecules to link up, forming the first RNA, the first proteins, the first fatty membranes. The pore itself, the mineral bubble, acted as the first cell wall. It contained the experiment, protected it, concentrated it. For millions of years, this process may have just been complex chemistry. Self-sustaining reactions, but not yet life. But one of these chemical systems, trapped in one of these pores, did something new. It created a molecule that could make copies of itself. Perhaps it was an RNA world, where RNA acted as both a gene, storing information, and an enzyme doing work. This replicating molecule began to compete for resources, for the building blocks in its pore. It evolved. It got better at copying itself. It eventually developed a way to make its own membrane, a fatty bubble, allowing it to leave its mineral pore and become a free-floating protocell. This was the last universal common ancestor, or LUCA, not the first life form, but the last one that is the ancestor of all life on Earth today. The evidence for this is deep in our own genes. The engine of all life, the one that turns food into energy, is based on proton gradients and iron-sulfur catalysts. We all carry the genetic ghost of the Hadean vent, the cradle in the dark. This event, the emergence of the first simple chemosynthetic, anaerobic, non-oxygen breathing cell, marks the true end of the Hadean. The planet was no longer just a geological and chemical system. It was now a biological one. The Hadean Eon closes, and the Archean Eon, the age of ancient life, begins. As life was taking its first, tentative steps in the dark, warm, abyssal plains of the Hadean Ocean, the surface of the planet was also undergoing a profound transformation. For hundreds of millions of years, the Earth's ground had been a fragile, temporary, black skin of basalt, constantly recycled or shattered. This was the first skin, the stagnant lid. But a water world is a geologically active world. The presence of a massive global ocean changed the very physics of the planet's crust. This is the story of the birth of continents and the beginning of the engine that defines our modern planet, plate tectonics. The basaltic crust of the Hadean was not uniform. It was riddled with volcanoes and fissures from the heat pipe system. It was also scarred by the massive impacts of the Late Heavy Bombardment. These impacts had punched deep wounds into the crust, creating areas of thicker and thinner rock. Now add water. Water, seeping into this hot, basaltic crust, acts as a lubricant and a chemical agent. When hot basalt rock interacts with water, it transforms. This process, serpentinization, creates new, less dense minerals and, crucially, releases hydrogen gas, one of the key ingredients for the hydrothermal vents. But on a larger scale, water allowed for a new kind of melting that in a dry system, rock melts at a high, fixed temperature. But if you add water to that rock, it drastically lowers the melting point. Water acts as a flux, allowing rock to melt at much cooler temperatures. This process began to happen in the Hadean. In areas where the ocean-soaked basaltic crust was thick, or where it was pushed downwards by an impact, it would get hotter. But because it was wet, it would begin to partially melt. And this partial melting is a magical process. It is another act of refining. When you partially melt a dark, dense, basaltic rock, the first liquid to sweat out is not basalt. It is a new, different kind of magma. A magma that is light, sticky, and rich in silica, aluminum, and potassium. A magma we call granitic. This new granitic magma was buoyant. It was far less dense than the black basaltic rock it was born from. It was like cream rising from milk. This molten, sticky magma began to rise, blob-like, pushing its way up through the denser basaltic crust. Couldn't punch through in a volcano because it was too thick. Instead, It pooled just below the surface, or on the seafloor, cooling slowly, crystallizing into a new kind of rock. This was the first continental rock. This was granite. The 4.4 billion-year-old Jack Hill zircons are our witnesses to this. They are crystals of zircon. Zircon crystals form almost exclusively in these evolved, silica-rich granitic magmas. The fact that these zircons exist tells us that this process, the wet melting of basalt to create granitic magma, was happening as early as 4.4 billion years ago. The Hadean, in its lulls, was not just a basalt ocean. It was a basalt ocean that was, in isolated spots, beginning to brew the first proto-continents. These were not continents like the ones we know. They were not vast landmasses. Geologists call them cratons, or more accurately, proto-cratons. They were small, buoyant rafts of lighter granitic rock, floating in a sea of dark, dense basalt. They were perhaps the size of Iceland or Japan. These islands of lighter rock had a critical property. They were buoyant. Unlike the first skin of basalt, which could be easily recycled, this new granitic crust could not sink. It was too light. It was unsinkable. When the basaltic plate it was on was pulled down or recycled, the granitic raft would be scraped off, colliding and merging with another granitic raft. This marks the true beginning of the continents. They are the scum of the planet, the light, frothy material that has, for 4.4 billion years, resisted recycling, floating on the surface of the convecting mantle. This process also may be the key to starting plate tectonics. A stagnant, global lid of basalt is hard to break. But a lid that is being weakened by water, pockmarked by impacts, and most importantly, punctuated by these buoyant, rigid plugs of granitic rock, is a lid that is ready to crack. The forces of mantle convection, the slow, rolling motion of the solid rock deep beneath the crust, could now grab onto the keels of these deep granitic rafts. The stagnant lid could be broken into a mosaic of plates. Once the lid is broken, the modern world is born and a new process, subduction, can begin. A plate of dense, ocean-soaked basalt can be forced to dive under a more buoyant granitic raft. As that wet plate dives into the mantle, it heats up, and the water it carries is released. This water rises into the mantle wedge above it, lowering its melting point and creating a chain of volcanoes. This is a volcanic arc. We see this today in the Andes, in Japan, in the Ring of Fire. This process, subduction, is a self-sustaining engine. It creates more and more granitic rock, making the continents bigger. And it drives the plates, pulling them apart in other places, where new basaltic crust is formed at mid-ocean ridges. The Hadean, in its final moments, was witnessing the birth of this engine. The first small, granite-like rafts, the proto-continents, were forming. They were small islands in a global iron-green ocean. They were barren, rocky, and lifeless. The toxic fog still shrouded the sky. But they were the first stable ground. Life, which had begun in the dark of the hydrothermal vents, was still confined to the sea. The land was sterile, baked by UV radiation, with no soil, no plants, no life. But the formation of these islands would have a dramatic effect on the chemistry of the world. As these granite-like rocks were pushed above the water by volcanoes, they were exposed to the acidic rain of the Hadean. When basalt weathers, it releases certain minerals. When granite weathers, it releases different minerals, particularly potassium and phosphorus, in large quantities. Phosphorus is the single most critical and often rarest nutrient for life. It is the backbone of DNA. It is the P in ATP, the energy currency molecule of every living cell. The creation of the first ground, the first proto-continents, and their subsequent erosion by rain would have caused a massive fertilizing event, washing phosphorus and other key nutrients into the oceans. This first ground was not just a stable place. It was the source of the fertilizer that would allow the new, fragile biosphere in the oceans to explode. The planet's geology and its new biology were beginning to talk to each other. The Hadean was ending, and the Archean, the age of ancient life, was dawning on a world of small granite islands and a green, microbially rich sea. As we cross the threshold, the arbitrary line humans have drawn at 4.0 billion years ago, we leave the Hadean and enter the Archean. The age of hell is over. The age of ancient life has begun. The toxic fog has not lifted, but the world it shrouds is fundamentally different. It is no longer just a chemical experiment. It is a living planet. Let's paint a portrait of this new, early Archean world. The Earth is still a water world, but it is no longer a global ocean. The first proto-continents, those small, buoyant rafts of granitic rock, have formed. They are not the sprawling landmasses of today, but scattered, high-altitude islands, perhaps the size of modern-day New Zealand or Madagascar. They are barren. No soil, no plants, no life. Just sharp, pale gray granitic rock and dark, volcanic basalt rising from the sea. The ocean is vast, and it is a strange color. The atmosphere is still anoxic, meaning it has no free oxygen. Without oxygen, iron is highly soluble in water. The Hadean oceans, rich in iron from hydrothermal vents, were a pale greenish-brown color. This is the green iron ocean. And the sky is still toxic. The sun is still faint, perhaps 25% dimmer than today. The greenhouse blanket is still in full effect, but its composition is changing. The atmosphere is still mostly nitrogen and massive amounts of carbon dioxide. But the methane, CH4, levels are now high and perhaps rising. The new microbial life in the ocean, the archaea and bacteria, is clustered around the hydrothermal vents, eating chemicals. But some of this life has evolved a new trick, a new form of metabolism. They are methanogens. They are microbes that, in the anoxic darkness, consume hydrogen, H2, and carbon dioxide, CO2, and, as a waste product, release methane. This is a biological turning point. The planet's atmosphere is now being actively polluted by life. This new, biological source of methane adds to the methane haze in the sky, creating a thick, organic, orange-brown smog. So, this is our world. A green iron ocean, dotted with gray, barren islands, under a thick, hazy, orange sky. A world of green and orange. This methane smog is critical. It reinforces the greenhouse effect, keeping the planet warm against the faint young sun. And it continues to act as the planet's sunscreen, the vital UV shield that the oxygenless world so desperately needs. The life in this ocean is simple, but it is life. It is single-celled, anaerobic, and prolific. It is evolving. For hundreds of millions of years, this is the state of the planet. Life exists in the slow lane, confined to the dark, chemical-rich oases of the vents, or in the slimy biofilms on the seafloor rocks. But in this world of green and orange, a new invention is about to appear. It is the single most important metabolic innovation in the history of the planet. An invention that will, over the next billion years, destroy this world and create our own. Sometime in the early Archean, perhaps 3.5 billion years ago, a new kind of bacterium evolved. It developed a new pigment, a new molecule capable of capturing energy, but not the chemical energy of a vent. It was a pigment that could capture the energy of the faint, diffuse sunlight that filtered through the orange smog and the green water. This was the first photosynthesis. But it was not the photosynthesis we know. It was anoxygenic photosynthesis. These bacteria would capture sunlight and use it to split a molecule to get hydrogen. But they didn't split water, H2O. They split the abundant hydrogen sulfide, H2S, gushing from the volcanoes and vents. They ate sunlight and rotten egg gas, and as a waste product, they released sulfur. This was a revolution. Life was no longer tied to the darkness of the vents. It could now colonize the entire sunlit surface of the ocean. These new phototrophs, perhaps purple or green in color, formed massive, slimy mats in the shallow waters around the barren islands. For millions of years, this was the advanced biosphere, a world of methane producers in the dark and sulfur producers in the light. The toxic fog was now a complex, living system, with life both consuming and producing its key ingredients. We see the evidence for this in the rock record. The 3.4 billion-year-old Strelley Pool Formation in Australia shows microfossils of cells that appear to be these ancient, sulfur-metabolizing bacteria. We also see the first stromatolites. Stromatolites are not fossils of creatures. They are fossils of structures. They are layered, mound-like rocks, built by vast colonies of microbes. These microbial mats grow in the shallow water, and sediment gets trapped in their sticky, slimy layers. The microbes grow up through the sediment to reach the light, and the process repeats, forming a new layer. Year after year, this creates a finely laminated, dome-shaped rock. The discovery of 3.5 billion-year-old stromatolites is profound. It tells us that by this time, life was not just a chemical whisper in the vents. It was a vast, robust ecosystem capable of building structures so large they fossilized. The Archean toxic fog was sheltering a thriving, global microbial empire. But this empire was on borrowed time. The planet was changing. The continents, those small rafts of granite, were growing. Plate tectonics was becoming more vigorous. More islands were forming. More land was being exposed to the acidic rain. This created a problem. The weathering of this new land pulled CO2 out of the atmosphere. The massive greenhouse blanket was starting to thin, bit by bit. And the volcanoes, while still active, were changing their chemistry as the planet cooled. They were releasing less hydrogen and more water. The sulfur-eating bacteria and the methane-producing archaea were facing a resource crisis. Their food, hydrogen sulfide and hydrogen, was becoming scarcer. The stage was set for another innovation. A new Kindorf bacterium, a descendant of the first phototrophs, developed an even more complex, more powerful pigment system. It found a new molecule to split. A molecule that was everywhere. It was water, H2O. This new process was oxygenic photosynthesis. It was incredibly difficult to invent. Splitting water is one of the hardest chemical reactions in nature. But these new microbes, the cyanobacteria, figured it out. They captured sunlight. They split water. They took the hydrogen for their own fuel. And they released the leftover atom as a waste product. That waste product was oxygen O2. This was the invention that would end the Archean. It would end the world of green and orange. It would poison the planet, kill off most of the life that had existed for 1 billion years, and plunge the Earth into its first and greatest ice age. The toxic fog, the methane-rich, CO2-heavy atmosphere that had nurtured life for 1.5 billion years, was about to be destroyed by the very life it had protected. The first and greatest mass extinction in history was about to begin, and it was all because a tiny blue-green microbe had invented a new way to breathe. We have traveled from a ball of magma to a living world of green oceans and orange skies. We have seen the planet forged in fire, shattered by collision, and shrouded in a chemical fog that, against all odds, nurtured the first cells that we have arrived at the end of the Hadean and journeyed deep into the Archean. But how do we know all this? The Hadean Eon is defined by its lack of a rock record. It is the dark age of geology. No mountains, no canyons, no cliffsides have survived from that first 600 million years. The story we have told is not a story read from a book. It is a story pieced together from echoes, from ghosts, from fingerprints left on younger objects. Telling the story of the Hadean is the ultimate act of scientific detective work. The primary clues, as we've seen, are the Jack Hill zircons. These microscopic, indestructible time capsules are the only physical relics of the Hadean crust. They are the heroes of our story. By analyzing their age from uranium lead dating, we know that a solid crust existed. By analyzing their oxygen isotopes, we know that liquid water existed. And by analyzing their titanium content, we know that the temperatures were low enough for granitic, continental-style rocks to form. These grains, found in a 3-billion-year-old Australian sandstone, are the anchors for the entire cool early Earth model. They are the evidence that the Hadean was not, at least not constantly, a hellscape. But what about the hell itself? The magma ocean, the Iron Catastrophe? That story is written in the sky, and in the heart of our planet. We know the core exists because of seismology. When an earthquake happens, it sends waves through the planet. By measuring how those waves bend, reflect, and change speed, we can map the planet's interior. We can see the liquid outer core and the solid inner core, and we know they are made of iron. We know the core formed early because of chemistry. The siderophile, iron-loving elements, like gold and platinum, are almost entirely absent from the Earth's mantle. They were all pulled down into the core during that great Iron Catastrophe. The fact that the mantle is stripped of these elements tells us the catastrophe was early, fast, and ruthlessly efficient. And what of the giant impact, the birth of the moon? That story is written on the moon itself. The Apollo rocks are the key. They show the moon is made of the same stuff as Earth's mantle, matching oxygen isotopes. But they also show it is dry, lacking volatile elements, and iron poor, lacking a large core. The only event that can simultaneously create a large moon, explain this bizarre chemistry, and set the Earth's spin and tilt is the giant impact. The moon is the Hadean's greatest and largest surviving artifact. The toxic fog, the chemical composition of that first atmosphere, is a story told by volcanoes and meteorites. By studying the gases released by modern volcanoes, we can estimate what the outgassing of the magma ocean would have released. It would be a stream of water, CO2, and nitrogen. And by studying primitive carbon-rich meteorites, the carbonaceous chondrites, we get a sample of the raw ingredients of the solar system. These dirty snowballs are full of water, ammonia, methane, and the amino acids that would later seed the oceans during the Late Heavy Bombardment. The Hadean fog was a mixture of what came from within, volcanoes, and what was delivered from without, meteorites. The faint young sun paradox is a matter of physics. We know how stars work. The models are precise. The sun was dimmer. And the solution, the greenhouse effect, is also a matter of physics. We know precisely how CO2 and methane trap heat. The only way to have liquid water, which the zircons demand under a faint sun, which physics demands, is to have a massive greenhouse atmosphere. The toxic fog is not speculation. It is a requirement. The Late Heavy Bombardment, that rain of fire, is a story told by craters. The moon's surface and the surfaces of Mercury and Mars are saturated with ancient basins. The Apollo dating of those basins all points to a narrow window of time, a cataclysm around 3.9 billion years ago. The LHB is the best explanation for this solar system-wide scar tissue. And the origin of life, that is the most profound echo of all. It is a story written in our own DNA. The core metabolic engine of every cell on Earth, from a bacterium to a blue whale, is the same. It uses iron-sulfur clusters as catalysts. It uses proton gradients, a flow of hydrogen ions, to create ATP, the energy molecule. This is not a coincidence. This is a shared inheritance. Our cells carry the genetic memory of an origin in a place rich in iron, sulfur, and hydrogen gradients. They carry the ghost of the hydrothermal vent. The Hadean is a lost world. We will never find a rock from it. We will never be able to stand on its shores. But its echoes are everywhere. They are in the spin of our planet and the tilt of its seasons. They are in the core that gives us our magnetic shield. They are in the moon that lights our night sky. They are in the chemical composition of our oceans. And they are in the very engine of life that powers our own bodies. We are the descendants of this lost world. The toxic fog was our nursery. The magma ocean was our forge. The Hadean is not a distant, alien place. It is our home. It is the first violent and forgotten chapter of our own story. And by listening to these faint, scattered echoes, we can, for a moment, drift back and see it. A world of fire, a world of steam, and, finally, a world of water, waiting in the dark for a new dawn. We have reached the end of our journey, a journey that has taken us across 600 million years, from the birth of a dust cloud to the birth of a biosphere. We have stood on the shores of a magma ocean, felt the jolt of a world-shattering collision, and watched the close, red moon rise for the first time. We have seen the planet wrapped in a fog of vaporized rock, and then in a choking orange smog of methane and chemicals. This was the Hadean, a time not of steady progress, but of violent oscillations. A world of fire, reset by a world of steam, which in turn collapsed into a world of water. A planet subjected to a 200 million year bombardment, a rain of fire that shattered the crust, boiled the seas, and, in a profound paradox, delivered the very organic molecules that would allow the story to continue. We have ventured into the greatest mystery of all, the origin of life. We've moved from the sunlit, warm little pond to the crushing, absolute darkness of the seafloor. We've found a cradle, not a pond, but a porous, mineral-rich chimney, a hydrothermal vent, a natural battery providing the energy and the concentration needed for dead chemicals to cross the threshold, to organize, to replicate, and to become the first living cells. The end of the Hadean is not an ending. It is the end of the beginning. It marks the moment the planet ceased to be merely a stage for geology and chemistry and became a co-author. Life had arrived. The toxic fog, that thick, greenhouse blanket of CO2 and methane, was the planet's first life support system. It solved the faint young sun paradox. It acted as an insulator, keeping the oceans liquid. It acted as a shield, its methane haze protecting the new, fragile life from sterilizing UV radiation. For 1.5 billion years, from the Hadean into the Archean, this fog was the guardian of the biosphere. But life is a force of change. The invention of oxygenic photosynthesis by tiny cyanobacteria was a biological event that would become a geological catastrophe. They began to release a new gas, a waste product, a gas that was corrosive, reactive, and deadly to the anaerobic life that had ruled the planet for eons. That gas was oxygen. For hundreds of millions of years, this oxygen poison was scrubbed from the oceans. It reacted with the dissolved iron, the iron that kept the seas a pale green. The iron rusted and fell to the seafloor, creating vast, thick deposits known as banded iron formations. These rocks, the source of all our steel, are the fossilized breath of these first cyanobacteria. But eventually, around 2.4 billion years ago, the iron in the oceans ran out. The oxygen, with nowhere else to go, began to flood the atmosphere. This was the Great Oxidation Event. It was the planet's first and greatest pollution crisis. This flood of oxygen attacked the methane in the toxic fog, breaking it down. The methane haze, the organic sunscreen, was destroyed. The potent methane greenhouse, which had kept the planet warm, collapsed. The toxic fog that had defined the Earth for 2 billion years was torn apart, and with the greenhouse gone, the faint young sun, still 20% dimmer than today, could not keep the planet warm. The temperatures plummeted. The planet, which had been a warm water world, froze. It became a snowball Earth, a global ice age that may have lasted for 300 million years. This was the end of the Archean world. The life that had created the oxygen was nearly wiped out by its own success. The world of green and orange was gone, replaced by a world of white and blue. The Hadean is the story of how to build a habitable world. It shows us a planet of unimaginable violence, but also of incredible resilience. It is a lesson in how geology, chemistry, and eventually biology are not separate stories. They are one story, a constant, shifting dance of feedback and change. The Hadean world is lost forever. No rock, no fossil, no atmosphere remains. But we are its legacy. The moon in our sky, the iron in our core, the gold in our vaults, and the very blueprint of life in our cells are all echoes from that first dark and toxic eon. And so we can settle back into our own time, back to this room, this moment, this blue and white world, with its clear, oxygen-rich air. The silence of the Hadean is the silence of a story that is finished. But it is a silence that, if you listen closely, contains the first notes of our own. If you enjoy drifting through these vast, quiet questions, exploring the deepest and most distant corners of our planet's memory, I'd be grateful if you gave this video a like. And perhaps, if you'd like to continue these journeys with us, consider subscribing. This quiet space for science and curiosity only grows when more people find their way here. Until next time, thank you for listening and rest well.